just record. Okay. Just so you guys know, I'm sick today, so I'm gonna try my best to, have some energy, but that's just to let you know. So, I'm gonna go ahead and screen share, so let me know if you guys could see that. Okay, so you guys should be able to see my screen, correct?
Yeah.
Um, okay. So welcome to our advanced Python workshop. This is presented by WorthyWorks Foundation Course. So in this course, we're going to be covering functions, which are pretty simple. These are kind of like the transition between beginner Python and advanced Python. It kind of depends on how complicated you make your function, but the concept of functions is pretty easy. Then we're going to be doing generators. Generators are also relatively easy. Data serialization. Now, the code for this part, it won't look that difficult. However, the concept is something that, I'll explain it and then you guys will understand, but it's not that easy of a concept to understand. So this is what we're going to be doing during day one. And then tomorrow we're going to cover concurrent programming and meta classes. So just before we start, I'm going to lay out our mission and who we are. So we are WorthyWorks, a nonprofit organization dedicated to providing STEM and other educational courses and activities with a particular focus on coding and technology-related subjects. Our mission is to empower children by sharing our knowledge and demonstrating that learning can be enjoyable and exciting. So I actually founded WorthyWorks when I was in 7th grade. Right now I'm in 10th grade. My name is Arnav Tripathi, and this is my peer, Devon Shah. He's not here today. He's in Florida. Okay, so first we're gonna start with functions. So as I said earlier, so functions aren't that difficult of a topic. They're essentially blocks of reusable code that perform a specific task when they're called. So let's say you have a big block of code that you want to perform multiple times throughout your code, but you don't want to keep writing those lines. By creating a function, you can store that code and in a variable essentially, and then you can call that whenever you need. So then instead of having to rewrite it, you can just call it and then your code will appear. So we're going to be creating a Fibonacci sequence using a function. And in case you guys don't know, it's a sequence where the sum of the two preceding terms is generated as the next term. So 0 and 1 equals 1, 1 and 1 equals 2, 2 and 1 equals 3. So that's basically what we're going to be creating, and we're going to have Python execute that. So this is just an overview. I'm going to give you guys the link to where we're going to be quoting this right now. I'll paste it in the chat. Um, I made it online, so everyone should be able to access this editor. Um, I'm going to go ahead and split screen actually. Um, okay. Can you guys see my ed? You should only be able to see my editor. You could in order to acknowledge what I'm saying, you guys could thumbs up or type in the chat, just so I know that you're here. Okay, I'm assuming everyone can see my editor right now. So we're gonna go ahead and start. So the function itself is defined by a single parameter. And in case you guys don't know, a parameter is just what is assigned to a function. You can't just create a function and then not assign it to anything, because then how are you going to call it? So we're going to assign a parameter to our function to generate the sequence. So first we're going to define it. We're going to say define generate underscore Fibonacci sequence. and then we're gonna have n. N is gonna be our parameter, and then we're gonna have a colon. Just make sure I didn't mess up the spelling. The colon. Okay, yeah. All right, Arav, I just noticed you joined back. We've just barely started, so I'll post the link to the editor again so you can use that.
Okay.
So this is the only line of code we have so far. This is just defining our function and assigning a parameter. And also, in case if you guys ever encounter errors at the end of when we're done with it, you can always let me know and I could look over your code, or I could paste my code in the chat and then you could compare and see where your error. And by the way, n represents an integer over here. Okay, so basically the number of terms that we want. All right, next we need to create an empty list so that we can store the sequence. In Python, in order to store data, usually you create lists or any type of something related to that, something that can hold your data. So what we're gonna do is we're gonna say sequence is equal to, and we're gonna do an open and close bracket. So this creates an empty list, right? So this is where we can store our data. Now we wanna create variables to actually create the Fibonacci sequence so that we can store some data in here. In order to do that, we're going to create two variables. And the reason we need two is because in order for this to work, remember how we have to add two numbers in order to get our third number in the sequence. So we're going to have two variables, tell Python to add them, and then have that as our third number in the sequence. So to do that, we're going to type A. A is going to be our first number. B, right? These are going to be our variables that are going to represent numbers. And we're going to set this equal to 0 and 1, right? So essentially what we did here is we have two variables here separated by a comma, and we have what is stored inside of these. So I'll give you guys a second to write that. All right, now we're going to create a for loop. So a for loop is kind of a basic Python concept. It's essentially used when you want to iterate through a code a specified number of times. It's similar to a while loop, except a while loop doesn't have a specific number of times you want to go through the code. A for loop, you specify that. So we're going to say for, we'll do underscore in range n. So in our range of n, remember n is our integer that it's our parameter that we assign to this function. In range n, we're going to do sequence dot append. So append is basically it's used to add on to a list. So we're adding on to this. We're basically adding on to the list and we're being able to store data. So we're going to do sequence.append and then A. So A we have defined over here. And then that's basically what this does. So we're adding on to A. And then we're gonna do A comma B, so the same thing we did over here, is equal to B plus A. Or you could do A plus B. Same thing. So what we've said here is that we want to add A and B, and then whatever that value is, we add it on to our list. So that's basically the Fibonacci sequence part of it. And then we're going to exit out of the for loop. So you can come back here. And so make sure you're not tabbed under for. So you want to be in the same column as for. And we're going to do return sequence. So this is just going to return everything to us. Now we've basically coded what we need to generate the sequence. Now we just have to define the number of terms. So we're going to get out of this function and we're going to say the number of terms. And we'll just set it equal to, I'm going to set it equal to 10. You guys can set it equal to whatever you want. You just don't set it equal to a number that's too high or else, it'll just keep on going. But I'm going to do 10. And then we do fib sequence. Is equal to generate Fibonacci sequence. So we basically called our function that we defined. We're calling this over here. So this is what I mean by calling the function, right? So whenever we need this piece of code over here, like let's say this was a huge program with a bunch of different parts. Let's say we needed this piece of code, we would just call this right here. And then whatever's stored in here would be executed, right? So we're gonna set that equal to generate Fibonacci sequence. And then we'll do number of terms, right? Because we defined this over here. So number of terms, this is what's going into n. N is our integer, right? And then we're gonna do print the Fibonacci sequence up to number of terms. I'll explain what all of this does in a moment. I'll just type it out. Terms is just make sure I got that. Okay, right. So what's happening here? So first, inside a print statement, we always have a string, correct? So we've initiated the string by having these quotation marks, right? So we printed the Fibonacci sequence up to, now it's going to print the number of terms that we defined, which is 10 over here, right? Sequence up to 10 terms, and then it's going to print us our fib sequence, right? So we've called it over here. It goes back here, and we've set fib sequence equal to our function that we defined over here. So now when we run this code, it looks like it's giving me an error. Line 13. Let me just make sure. Oh, make sure over here you have a B, comma, A plus B. So I forgot to add this here. So B was our last was our last sequence, our last term in the sequence, and then we're adding on a plus b. Okay, so that was my mistake over there. I'm gonna run this again, and then over here, we see it has printed the Fibonacci sequence up to 10 terms. So it gives me 0, 1, 1, 1, 1, 2, right? So it gives me my 10 terms that I define. Now we can change this. Let's say I make it 15, and it's going to print 15 terms. All right, so that's basically how functions work. Is everyone's code working? Does anyone have any questions so far? You can type it in the chat, raise your hand. I'll go ahead and also paste this in the chat, so in case yours isn't working, you can copy this. The tabbing might be messed up, but this is basically the code. All right. So if your guys is working, you want to go ahead and just save this. So you can save it to this. You can name it whatever you want. I'm not going to save it. Actually, I'll just save it to show you guys. I'll call it main.py. Yes. And then it's going to save to, wherever I need. You can save it to whatever folder. Okay. So that's just how to save your code if your code is working, right? I'm assuming since nobody said anything that everyone's doing fine. I'm gonna go ahead and move on to our next piece of code. I'm just gonna delete this, but you guys should probably save your code. Okay. Let me just stop sharing and reshare to the slides. All right. So next we're moving on to generators, okay? So generators are essentially special blocks that yield one value at a time. And generators are used for efficiency. To be more specific, memory efficient. So like you could think of the number, like let's say pi, right? Pi goes on forever. In Python, there's only so much memory you have, or just in general, right? In just IT, there's only so much memory you have to store all your data, right? So we're always working to essentially compress our data, minimize it so that we can get all the information we need without taking up more space. So generators, they provide ways to generate and retrieve values of all on-demand data, and they make it useful for large or infinite sequences. So in this example, we're going to create a generator that generates like squares of numbers. 2 squared is 4, 3 squared is 9. And it's going to be up to a given limit. And it's not going to have them store everything in memory. So that's basically the benefit of generators. Now this is just a look at our code. Let me screen share again to our editor. All right. So just like we did with our Fibonacci sequence, we have to define a function here. So, functions are used everywhere. So we're going to define generate underscore squares. And then we're going to set this equal to a limit, right? Our parameter to this function is going to be limit. This is how much we want our function to generate. Similar to our Fibonacci, we're also going to run a for loop here. So we're going to say for I in range limit right? So this is essentially the same. We've basically done the same thing that we did in the last one. We've defined our function here, right? And then we've written a for loop, which is going through our limit using the range, right? Now what we're gonna do, make sure you add a colon, by the way, so make sure you're tabbed under the for loop. You're gonna do yield, then you're gonna type I, right? We defined I over here, so it's gonna be our integer. You're gonna do two asterisks. So basically what this does, one would mean multiplication, two means raising to the power of. So we're gonna raise this to the power of 2, right? So that's how we generate the squares of numbers. So we want 3 to the second is 9, 4 to the second is 16, etc. So that's how we're generating the squares, right? So it allows us to return a value and then resume where it's left off. So that's actually it for what's going to be inside of our function. Now we're just going to define how much we want. So make sure you're not under the for loop anymore. And you're also not under the function. So what you're going to do is squares dot gen, and you're going to set this equal to generate squares. So what we defined up here, right? So we're setting our function equal to squares dot gen. And then now we just need to call it. So to do that, we're going to have another for loop. We're going to do for squares in squares dot gen. Also over here, I missed it. Squares dot gen generates squares. We need to assign it our limit, right? So this is our parameter. Again, you can set this to whatever you want. I'm just gonna do 10. So then we're gonna do for square in squares underscore gen, right? That's we created here. Make sure this is underscore. Actually, it doesn't matter, but that's just what's written in the code. So that's what I'm going to do to just make it easier for you guys if you're following the slides. So for squares and squares underscore gen, we're going to have a colon, and then we're going to do print squares. Okay, so basically what we've done here is we've defined our function, we've defined what it does. So in this range, it's raising everything to the power of 2, right? And our limit, which is our parameter, this is our range of 10 or whatever you've done. Then we've set our generate squares equal to squares.gen, right? And then we call squares.gen by using a for loop. So for square and squares.gen, we just print our square. Now, if I run this, here, it's printed all 10 of my squares. So 0 squared is 0, 1 squared is 1, 4 is 2 squared is 4, 3 squared 9, 4 squared 16, and so on. So these are our 10 squares that they printed. Does everyone understand? Does everyone have this code? Any questions? I'll go ahead and paste this in the chat. You guys can go ahead and save the code. It should be the code. All right. You guys can go ahead and save the code if you want. Just like I showed you earlier, just save file to disk, name it whatever you want, and then save, right? So save it wherever. Okay. Next we're gonna move on to data serialization. The code here isn't gonna be like it's not going to be very representative of what data serialization actually does. Because what we're going to actually do is serialize the data and then deserialize it within the same code. So it'll essentially cancel out, but that's just to show you guys how it works. So let me just reshare to the slides. Okay, so data serialization is essentially the process of converting data structures to portable format. So basically what you can transfer over the web, right? Big companies use things like GitHub, basically different softwares to transfer data over the web. So serialization is the same thing. So transmission of data. So it allows data to be represented as a string of bytes or textual format, which can then be deserialized to be, used, right? To be used in code. So we're going to be using JSON, which stands for JavaScript oriented notation. And this is widely used, and it's an interchange format that is human readable and easy to work with. So you probably have seen this at the end of files sometimes, right? So when you're downloading it, right, you download a JSON file and then it's deserialized so that you guys can view. But the actual transmission, it was serialized data. Okay. I'll go back to the code now. All right. Okay. The first thing we have to do is import a module. So in case you guys don't know, modules in Python are just it's pieces of information that, okay, also this meeting ends in 10 minutes. I think we'll be done in 10 minutes, but in case we aren't, I'll post a new link for you guys and you guys can join that. Okay. But I think we can wrap it up in 10 minutes. So as I was saying, modules are just pieces of information that Python sometimes needs to be imported so that it has different libraries of data. Not everything is just stored locally. So we're going to do import JSON. So that's just importing our module so that we can serialize our data. And we're going to do data is equal to, now open open curly bracket. And then inside here, we're going to store some information, right? Once your curly closed appears here, make sure you're inside of the open and closed curly bracket, okay? Let's just say we want somebody's name. We're going to say name, and then we're going to do colon. You can name it whatever you want. We'll just do what's in the example, John Doe. So you could write your own name, actually. And we can write our age. I'm 16, I'll set it equal to 16. You don't need to put this in quotation marks because Python registers this as an integer. Only like letters, right? You need to put these in quotation marks so that it's inside a string. So we're gonna say age is gonna be 16, and we're going to put a comma, and then we'll do our city, right? So we'll do city, and I'll just say Edison. So I live in this. Okay. Now, so this is where all of our data has been stored, right? Under this data variable. Now we can exit the curly bracket, and outside of this, so now what we want to do is serialize this. Now, this is not really a lot of data. There's no need to serialize this. This is just to show you guys how it works, right? So in order to serialize, this is the command you use. So you do JSON underscore data, right? This is just our variable, and we're going to set this equal to JSON dot dumps, and then data. So what we've defined over here. Okay. Um, so basically this just converts the Python object into a JSON formatted string. Okay. So this is basically a JSON variable, right? So this is what serializes the actual data, right? Next, we're just going to deserialize it. So this is what I was talking about, how it's not really a great representation of how the actual process works, because in order to do that, you'd need to collaborate with other people, actually transfer the data. We're not going to be doing all of that here since it's too complicated, but just to show you guys how it works. So this is the command that serializes the data, and this is what deserializes the data. So deserialize data is equal to JSON dot loads, right? So here dumps, here's loads, kind of antonyms of each other, so you guys can figure out, which one serializes and which deserializes. So we're gonna say JSON.loads, and then we're gonna do JSON data, which we define over here. So it's taking this data and it's deserializing, right? So the actual command is JSON.dumps and JSON.loads for serialization and deserialization. So this is what has deserialized our data. And now in order to print this, we're just going to do print deserialized data. Remember, we can't print data that is serialized, right? It's just what is deserialized. So now if we run this, it's going to give us whatever was inside, right? It gives us our name, age, and city, all of that. Okay. So that's basically how serialization and deserialization. I'll paste the code in the chat. Does anyone have questions? Any issues with their code? Um, all right. If not, I'll go ahead and conclude. So remember, if you guys have anything, you can always just let me know. I can help you out. If you guys are good, then I'll go ahead and okay. Let me just close my editor, go back to the slides. All right. So before we conclude, this is like a homework oh yeah, no problem. Um, sorry, I was just replying to chat messages, but you're welcome. Um, so you guys can attempt this if you'd like, if you want to take a challenge for yourself. Um, so this is what you're gonna do. You're basically gonna write a function that called count vowels. So basically what we did over here with functions, right? Similar to this, similar to generators. And you're gonna take a string s as an input, and you're gonna return the count of vowels. So uppercase and lowercase. This is a little bit tricky, so I'll give you guys a solution to this, tomorrow if you'd like, if you do attempt it. But it's just a challenge. If you guys want to do it, you can do it. If not, it's so this is an example of how. Okay. So that basically wraps up our session for today. Um, any comments or questions, you could ask me right now or email me, anything like that, post it in the classroom. At the end of the 2 days, recordings of the sessions will be posted. We also have all the material. So, everything is there. Um, okay, I'll put my email in the chat for everyone. My personal email, you guys can email me there. if you have any questions, information about future classes, anything like that. Um, but yeah, if you guys are done, then you guys are good to go. Thank you, everyone.
Thank you.
Yeah, no problem. Yeah, so the recording for basic Python, it's on I have a YouTube channel here. I'll also post that in Classroom, but I'll give it to you right now. I have a bunch of stuff there. I have like AWS, um, different types of, you know, coding. I have Scratch, Java, I have everything. Uh, so here's the link to the YouTube channel. You can find all like the relevant videos here. Yeah, no problem. All right. Okay. I'm gonna go ahead and end the meeting if you don't have any questions. Anything else?